Hello friends, welcome back. We are on 34th module of this particular course. We are coming to an end, last 3 modules. This 34th module and subsequent 2 modules are dedicated to IoT, Internet of Things. We hinted about that in module 6. We talked about IoT is something which is a very tiny small device, sensor like device. Additionally, it has a capability of talking to internet, communicating with cloud, and enabled us to communicate to the rest of the world using that. The very idea of having an IoT as part of a network makes the network itself is a very different vision of a network. For example, according to one prediction, by 2020 we will have nearly 70 billion devices connected to internet. That prediction may be wrong, but then number of devices connected to internet will outgrow computers soon, and the entire vision of networking is going to change. We have talked about smart cities and we have talked about smart home and all that in module 6, and we have seen that this is something which is coming up. The people have done a lot of things in IoT, and there are many things which are happening in IoT, but we will be concentrating on the networking aspect of IoT in these 3 modules that are coming. In this first module, we will be talking about what exactly these IoT is, what kind of sensors. We already have seen that sensors are interwoven in the human life, they are already part of it. For example, the motors that we run, the ACs and all that, they all have sensors today, and they have become IoT based sensors. For example, our TV is connected to sensors, and TV communicates to the manufacturers. You probably are not aware, but many cases a TV manufacturer can learn what the kind of TV programs you watch and all that. Okay, so that is possible, and in fact there are solutions of that kind. So many things are like that are happening. It has become interwoven in our life. We don't realize that it is there, but it is so. Okay. So there are 2 things here. First thing, the applications that we have talked about. For example, we talked about SMTP, STTP and those applications. Those applications we communicate with those applications. For example, STTP, human being run browsers and web servers and all that. So people communicate with those applications. When we talk about IoT, it is something different. IoT is something which works on its own, you do not interact with them. For example, embedded sensor in a TV which records what we are doing, communicates directly there, and we will later on see display boards in the malls also have interactive IoT devices embedded in it, but they do not have an interface like this thing. People do not talk to them, the machine talk to machine, okay, and that is called M2M. That is happening. In fact, sometimes human need to communicate to such devices. So human to machine interface, human to machine is something different than communicating with a browser or a web server. So S2M also is happening today. So those things, we will be hinting about those things earlier, we will be throwing some more light during these 3 modules. Okay. For example, one case is I have an insulin pump embedded in my body, and I may also have a glucometer. So glucometer finds out the glucose level of my body and talk to that insulin pump, and exact dosage of insulin is decided based on this reading. So these 2 devices communicate. An automated car, you probably have heard about Google's automated car, and there are some other companies who have come out with automated cars. They have thousands of sensors inbuilt, and they talk to each other. The front camera and the back camera, tire pressure and all those things communicate with each other to get a complete picture, and that is how a car can navigate itself through the crowded lanes. So that is something which is happening, which will be throwing more light on that. For example, devices talk to their surrounding, adjust to ambience, work as per specification. For example, it is possible to embed such things in walls of your house. Intel has come out with this smart home concept, and they have already built something called a smart village. So, those walls actually can interact with you, they find out your own preferences, they have means of identifying you by many things, including your footsteps and your weight and all that, and they will be able to learn about your preferences, adjust cooling temperature according to your preferences, adjust music according to your preferences, lights and all that according to your preferences. This thing can actually happen. So, that is happening. Okay. So, for example, insulin pump I talked about, embedded intelligent systems communicate over internet. Now, these things, they are not confined to home or something, they can communicate with internet, and such smart homes are actually, one can manipulate home sitting at his office. For example, a door, my intelligent door may recognize that a stranger is standing in front of it, will send me a photo over internet, and wherever I am, I can look at that, find out him to be my friend, and I can instruct my door to open. So, that is something which is possible. Home networking solutions like smart lighting, smart meter, remote control, we have already discussed about most of them in module 6. I am not going to discuss more about, but remember what we discussed. The list of that is available on the screen. Smart appliances we discussed, smart buildings which can learn about their inmates requirement and change accordingly, provide their readings and so on and so forth. Smart vehicles which can avert accidents, smart cities which can learn from the data and take decisions in favor of their citizens' comfort. So, those things are happening. Okay. The devices, these are the characteristics of IoT devices. First thing, they self adjust. Okay. For example, in a surveillance camera, it finds out that the surrounding light is reducing, maybe a cloudy weather or night falling, then it will start change the exposure or even switch over to night mode vision, that is called self adjustment. So, you do not need to tell, it will learn on its own about the surrounding and adjust accordingly. Okay. So, that is the first thing. Second, it will self configure itself. What does that mean? Self configure means when it attached to a network, it understands the parameter of the network and act accordingly. Okay. So, if the network demand a specific set of commands, we will start providing those commands, start working on a specific protocol, different, and there are hundreds of M2M protocols, and many M2M protocols are not IoT based. So, it is quite possible that somebody manufacture a device which works in multiple such networks. So, can talk to machines in their own native language and solve the problem. Okay. So, that is self configurable. Self configurability from networking point of view is one great thing, finding out his own IP address and start using it in the network. Okay. So, it can work with multiple protocols depending on the situation. I already have talked about, have unique ID to recognize world over, and usually IP version 6 address is given to an IoT device. Okay. Communicate and collaborate. Now, this is important. Communicate is, the difference between communicate is that you just pass information and forget. Collaborate means you both of you talk to each other and find out some solution. For example, two vehicles moving or multiple vehicles moving in a smart city case, figure out the amount of vehicle at a crossroad, figure out amount of congestion at different crossroads, and such a system will be able to tell you exactly which path to take given a destination depending on the amount of congestion. Now, this is something where everybody collaborate. Okay. So, that collaboration, and we will take some other examples later also, different networks collaborate with each other using IoT. So, collaboration is the power of IoT device, not communication. Communication is passing the information from one to the other. Now, they collectively take a decision. Collaboration means they collectively take decision by exchanging information. So, we will elaborate that further. Here you can see that the example I have already given. One more word which people use are called embedded system, and IoT is actually an embedded system with internet enability. Okay. So, embedded system is basically a sensor which sense the environment and act. Okay. For example, IoT chip embedded in a surveillance camera makes surveillance camera an embedded system. a chip in a glucometer makes it an embedded system. Okay. So, an embedded system, after sensing, there are three phases of any embedded system. They perceive something, they process that, and then they actuate that. Three phases: perceive, process and actuate. Okay. However small those devices are, these three phases are always there. Okay. So, that the embedded system or IoT device, they have these three: they perceive, they learn something, they process that input and then take a decision. For example, insulin pump learn about the insulin level of somebody's body, process that thing and decides to pump some amount of insulin in the body. So, that is actuation. So, that is how it works. It may take multiple sensors. For example, in case of AC, it contains quite a few sensors. For example, one is air flow, temperature inside, temperature outside, and also takes the input from user. Okay. So, user has already provided his preferences, and these sensors will also give additional preferences. The AC, however dumb that device is, can actually take decision about everything, and the amount of cooling and all that is adjusted according to all the sensor values. And when the sensor tells that the AC that the required temperature is achieved, AC automatically stops itself, and whenever it goes beyond that threshold value, it again restarts itself. So, that kind of control is done. Okay. And you can see that there is no interface here. The interface, it does the job automatically, though there is no interface as such. All our mobile phone, printers, street lights, they have all embedded, they are all embedded systems, they have sensors there. Here are some examples: vehicles smartly averting accidents by sensor embedded in them, maneuvering automated cars through crowded roads. Now, these does not happen on its own. There are a lot of sensors which are talking to each other for making this decision. For example, the automated car have multiple camera sensors, they have audio sensors, GPS sensors to detect where they are, road sensors to learn about the condition of the road, and so many other things. Smart surveillance cameras are designed to learn on their own. They know that this is normal and this is abnormal, and when somebody is running found running on the street with a knife or a bomb, will recognize that this object is something which is not acceptable and can take an action on that behalf. So, it is no longer a surveillance camera which is dumb, it acts like a security guard. That is possible. IoT based solutions actually can detect such object, inform the police over the cloud, and the nearby police van will find out using GPS that thing nearby police van, and may even invite that police van to that place, provide his own location also. So, that kind of system is already there in place. It is not that I am talking about something which probably happen in future, it is already there existing. Okay. Smart home cameras learning about inmates, we took one example of somebody sleeping, okay, babysitter sleeping. Okay. Collect patterns of usage. Now, this is one more thing, it looks at the patterns of usage and decide about something. Smart city case will decide the amount of water being consumed and will tell that the water resources that we have are falling short. So, find out. So, the municipal corporation will have ample amount of time to adjust or make sure that the water level, the adequate water levels are provided for solving this problem well before that actually strike the city. Okay. Is basically is a big data analytics problem. There is lot of data coming in. We discussed that thing again when we discussed module 6. That is a huge amount of data pouring in, and when that huge amount of data is pouring in, and lot of types of data coming in, and all those data are to be processed, it makes it big data problem, and sorting that thing out, getting some decision out of it requires analytics. So, that analytics is big data and analytics problem. Okay. So, it is not all that simple thing that we could talk about. So, here the communication part is very critical. Remember, communication and collaboration are two essential components of an IoT device. We took that example, sensors in a burning building can guide through a safe passage. A car is approaching house, the sensors inform the heaters of the house. Now, this is not about India, it is about places like Canada and all that, where there is a huge this thing, huge amount of snowfall and all that. Most of the time in the winter you will have a very cold atmosphere. So, when your car is approaching house, that car sensor will communicate with the sensors of the heater and the heater will start on. So, when you reach home, you will really have a warm welcome. Okay. So, not only that, water dripping sensors are there to, and they will find out the amount of water in the soil and pour only the amount of water that is needed by the plantation that we had there. Okay, sensor embedded in public places, warn about wear and tear of for example, bridges, and will be able to tell you exactly what kind of vehicles, how many vehicles are passing through, what is the stress it is undergoing, what is the capability and what is the problem, and if there is a need for strengthening, it will inform you well in advance. Smart meters we discussed about, this thing we have already discussed. So, I am not doing that. In fact, this is just repetition of what we did in module 6. Interestingly, grid of smart bulbs is also there, and so whenever in the entire building there are thousands of bulbs, I do not need to go out and check each and every bulb. On my own laptop, I can communicate with all those smart bulbs, and one of the bulb will tell me that I am going to die soon. Okay. So, I know exactly which bulb I need to replace tomorrow. Is kind of solution that are possible. Okay. Now, this is again an interesting example. Okay. So, for example, if you have ever visited malls, you probably have seen big display units. Those display units display ads in front of you, and you probably have wondered who is managing all of them. You may not know, you probably have some idea that the mall owners are displaying those ads there, and you probably are right in that context, but then you may not know that there are two different inputs coming. The timings and the placement of that placement of that advertisement is decided by the mall owner. For example, they may decide that you should go to a ladies section, they should go to a kids section, and so on and so forth. And they also decide the time as well as the duration of that advertisement. But the ads, in most cases, they are not stored at the store. The display units have an embedded IoT device which can communicate over cloud, and from cloud it fetches the advertisement. For example, you have a new ad of a company. Okay. Let us take an example of new phone. Okay. There is a new phone and the ad is available. So, that ad is copied to cloud by that company, and this display unit just fetches that and display it over here. The advantage is that the company does not need to go to every mall and install that ad there. No, they do not need to, they will only install it in the cloud, and the display units will get it from the cloud. If there is any difference, any change, a company can do it, reinstall that ad with a single click, and after that every display unit everywhere in the entire country will start showing a new ad. So, that is possible. Okay. So, this is usually the case, and that is, you can see the example of communication power that we have. The company has that power, can change the ad as and when they want. The mall owners have their own power, they can display the ad for the amount of time they wanted, for the place that they wanted, based on the amount of money that the other companies which are displaying their ads to them, and so on and so forth. So, this is an excellent solution. Interactive IoT devices is something that is the need of the hour, and which is IoT display boards I talked about. Can actually become interactive. You probably are not aware, but many display boards also carry a camera with them. They monitor you, and that they send this information, they churn that information and send it back to the cloud. For example, a new mobile phone ad that you are watching probably is also watching you from the top. There is a camera which is looking at you. Not only that, it runs a lot of AI based algorithm, will find out your gender, your age, will try to guess your age, try to find out whether you are seriously interested. Okay. You show willingness, and also then trace you later whether you go to that thing and inquire about that phone, or have you really gone and purchased that item. So, not only this thing will also take lot of other inputs and will pass that information back to the company which has presented this ad to you. So, this is something which is interactive, not only it is displaying things to you, it is also taking some information and passing it up. Okay. So, company can design marketing plans accordingly. If they find that only kids are watching them, then they try to address kids or something like that. Okay. Here is one more example. Okay. And I have already talked about the surveillance case where you need to communicate, and one more example is machine health monitoring. So, if there is a factory, there are a lot of machines and there are sensors built in, the sensors communicate with each other, learning about the machine health, and that thing is informed back to the company. So, the company can take decisions about machine health. So, they may probably need a preventive maintenance or need to be replaced, some parts needs replacement, all that kind of a thing can be easily managed. Okay. Well, the breach example that I gave, the stress and all that is calculated and sent to the estate department of the municipal corporation. Municipal corporation will be able to see that there is a serious wear and tear, and they need to like strengthen the breach and so on and so forth. So, that kind of interactivity is something which is special about these IoT devices. Not only that they interact, they communicate this thing further. Example, surveillance camera talking to a police van using this information, machine health communicating to be, in fact, they can say that when that can be scheduled and when this can be reported. Can also be used from control from remote place. Okay. So, like water pumps can be remotely maintained. Okay. It can coordinate with other IoT devices. For example, if an IoT a camera finds out that this guy is a fugitive, is escaped from custody. Okay. It can match with the database and can find that thing out and can help police to figure out that this particular person is a fugitive. Okay. So, that is communicating, not only it learns about the person, the surveillance camera not only learning about that person, will be able to process further, match that thing in the database and can inform the police, that is possible. Okay. So, passing information about water usage to the water department, telling that this is the consumption of water and we are likely to run short of water if the consumption is going to continue this way. What kind of networking infrastructure that is needed by IoT? Now, we will talk about. It is predominantly wireless, will have to be wireless in most cases, but in other cases it is, even if it is possible to be wired, we would prefer it to be not, because in case of mall, display boards are usually static. So, we can have a wired network connection, but even in that case they are needed to be moved from one place to the other. So, wireless is the thing that is the case with IoT. Okay. What we want is, we want energy efficient solution where changing battery is not expected. You would like run the batteries to run for a very long period. It hardly sends data actually. So, it does not require large bandwidth for most of the IoT applications. Some IoT applications are different, I am not talking about them. Okay. For example, IMDs send very little amount of information, the glucometer read and send only an integer kind of. Okay. So, it requires a better frequency band which can use low power, and methods also will use less power and memory. This is needed. Okay. So, IMDs they have cap on power because of the other reason, because human body can be actually, it will harm human body if you use more power. This is precisely what we want. Low bandwidth short and long distance communications are favored. And there is one protocol, 802.15.4 is an IEEE protocol suited for such applications. Zigbee is vendors alliance of products based on this protocol, is very similar to Wi-Fi. Okay. So, what Wi-Fi was for 802.11, Zigbee is for 802.15.4. So, now let us talk about this 15.4 further. Is low power, low bandwidth wireless PAN, personal area network. Why personal area? Because the distance is pretty short, 10 meters is the first version. There is another version with 100 meters, but it demands more power. So, hardly ever that is used. Okay. 802.15 is WPAN working group. So, 15.4 is the one that we are talking about. Is designed for mesh networks. We will soon see what is mesh, and very low bandwidth. In this case, this thing 15.4 uses only 127 byte data, okay, and the addresses are only 16 to 64 bit. Range is 10 bitters, as I said, reserved time slots before, and it uses CSMA which we have already used. Maximum data rate is 250 kb per second actually, but this is hardly ever needed. People use 10, 20, 40 and 100. If you use lesser power, okay, lower range will get more power efficiency. Here are some ranges which are used. First is Europe, the second one is North America, and third one in countries. There are some others added. Okay. The older methods do not use OFDM, but some newer methods with OFDM are also proposed. There is one more version which uses channel hopping like FHSS, which we looked at long back, and which is on this line 750 megahertz and 950 megahertz, which is the first ISM range, which if you remember. Okay. No range is useful for long distance communication. So, this 802.15.4, one of the drawbacks of this is that for it you cannot use it for longer range. Here we cannot even use star topology. Okay. So, that is the problem. What the problem is? See, there are few problems. First thing, let us take an example of our own home. Okay. We have one sensor, one router which is there in the drawing room, and there are many other devices scattered across the house. Now, distance cannot be more than 10 meters, means only 30 feet or something, that is first. Second problem, house is not built for computer communication, unlike computer labs, and there are many obstacles like walls and pipes and so on and so forth, and a lot of other things are also happening that reduces the range further. So, it is quite possible that every node is not reachable. So, it is impossible to have star. In fact, the best solution is to make sure that if your device is further, if the central router can communicate to all, it is best. If it is not, then it has to communicate via some other node, and if that happens, we call it mesh network. So, this is precisely what we are going to talk about, the mesh network. Okay. ZigBee, as I said, provides 100-meter range, but hardly ever it is used. Okay. A mesh network is a network of arbitrarily placed objects in the house, and everywhere it is. In fact, you can what is the best topology if not star? Simple, it is very similar to MANET. So, we have dynamic and flexible topology, but it is basically steadier. So, we will use the central router. Now, the word, remember, the central router is only one router that we have. Usually every house has one router, is talking about that router. There are some other words used later, one is called central coordinator, one more is called border router, and so on and so forth. There are multiple central coordinator is one more word which is being used. So, there are multiple words used to describe the same item. Okay. So, here we are calling it central router. Okay. Best if directly connected, otherwise through other devices. Now, that is the mesh network. Okay. How mesh is constructed? Again, it is very similar to MANETs. Okay. So, first of all, router broadcast is presence. So, whoever listens to it are directly connected to the response back, and router will learn about. Others, now these nodes start broadcasting on their own. So, if some other nodes which could not be reached by the router probably are reached, and they will respond back, this information is relayed back to router. Eventually, router learns about everybody else, and that is the reason why this thing is called self learning, self organized mesh. Okay. So, they organize on their own. A mesh is basically every node is connected to every node. Okay. So, when you broadcast, you know whoever are eventually, but you will not use all lines. Okay. So, it is not exactly in that fashion mesh. Okay. You are connected to all in surrounding, but you will not be sending information to all. You will not be broadcasting except in this particular case. Hardly ever broadcasting is used in this particular 802.15.4 network. Okay. The second thing, once they decide, okay, once they find out their all surrounding all nodes, the second thing that they need to do is to find out the best path. And here the best path is not only the shortest path, because everybody is reachable through one hop. So, there is no comparison there, but you also look at many other things, how good this link is, what is the battery available, and so on. Okay. So, if there are multiple routes, they will decide based on something called an objective function, which is basically based on both capacities of node as well as link. Okay. So, is based on that it will decide these paths. Okay. So, as I said, only one link is used at the later stage out of all of them. Okay. The central router is sometimes known as full function device or FFD, and many small tiny devices which do not have the amount of memory and processing power, they are known as reduced function devices or RFDs. Okay. And in a normal mesh network, it is quite possible that you have more than one FFDs. Okay. But there is always going to be one FFD which is central router, there may be more than one FFDs, and there may be more than one RFDs or reduced function devices. Reduced function devices are very small devices with less memory, less power. Okay. As I said, the word central coordinator or FFD sometimes used instead of this thing. Okay. So, it also connects to other networks, because please understand, this home network is not alone. As I said, this is IoT, so it will have to connect to the world. So, all these mesh devices, they need to talk to the world, and they do not have power to talk to the world, they do it via this central router. Okay. So, this central router is connected to the world, and every device communicate to the rest of the world through this central router. Okay. So, that is why it is also called a border router, because it sits on the border and will help you communicate to the rest of the world. We conclude this module. What we looked at in this module are a few things about IoT. Internet of Things is something which is emerging, and it has plenty of applications. We have looked at some of the applications in module 6, and we have reiterated about those applications, smart CT, smart metering, and all those new things which are appearing on the horizon demand using IoT devices. IoT devices are very good, but the problem is that they introduce new problems, because these devices are much smaller in size, they have memory problem and processing problem and all that. Okay. So, we need a typical type of networking solution for them, and in this particular module we have started talking about mesh networks. Mesh network, unlike the conventional star topology, is where you connect to all of them and then find out the best path to the node, next node. Okay. And we have seen how that is done, and that is why they are called self organized mesh. They learn on their own, and we have also seen that this devices communicate with everybody else, and that communication, not only communication, but the collaboration, they work together in solving problems, makes them more powerful. And we have seen some examples of collaboration. For example, vehicles averting collision, their sensors talking to each other, finding out the distance between them and then averting collision is one example. Insulin pump communicating with glucometer is the other example. There are many such examples one can quote, and that is the reason why they do not have a human like interface. They have a different kind of an interface, they have machine to machine communication and so on. So, there are many new eras, there is many new vistas of challenges there in IoT. With that note, we will conclude. We will talk further about the same in next subsequent 2 modules. Thank you, friends.